Hi Pasha, how are you?
I'm Mr. How are you?
I'm good, Pasha. Pasha, just give me a moment, I'll begin.
Okay.
All right, Pasha. So, where were we?
Um, you say in our last class you gave me some questions about proving identities.
But we discussed them in class, didn't we?
Yeah,
So, we were done with them.
yeah.
That's nice. Now, today, let's move on with trigonometric equation solving. All right.
Okay.
So, up until our last class, we had done your how to prove identities. All right.
All right.
Now, what we're going to do is that we're going to move forward with, oops, solving trigonometric equations. All right.
All
Similar
right.
to identity proving, it's just that the examiner always, the examiner is, these are the only two types of questions that the examiner is going to ask you. Hmm. All right. All right, Partha, let's continue. Apologies about this delay. Just give me a moment. So, Partha, whenever we're trying to solve equations, it's a very easy process, similar to how we've done what you may call um, similar to as if you know how we've done the identity proving, but this time around it is going to be much more easier to do or to solve trigonometric equations because there is a set method to do so. All right, there's going to be a couple of steps, and those steps are going to be, they are only those steps are going to be enough in order to solve any trigonometric question. All right, so that is going to be the case. Let's continue forward. And it is extremely easy to do so as long as you keep on following these steps. They're going to make sure that you score highly on this as well. So we saw above that two types of questions can be asked of you. One was proving the identity, we've done that. Then was solving the identity. All right, so now today we're going to go for equation solving. All right.
All right.
Just a moment, Watson. All right, let's continue. So, Varsa, if I'm solving an equation and specifically a trigonometric equation, it is going to involve some steps. First of all, you have to, okay, let's try to do this with the help of an example. So let's just say that we have an example which states that 4 cos square theta plus 5 sine theta is equal to 3. Okay, let's try to use this example. Now, if 4 cos square theta plus 5 sine theta is equal to 3, Now, the first thing that you need to do, regardless of anything in the world, which is step one. So, step one is that you're going to have to express the given trigonometric equation in a single trigonometric identity. So you're going to make sure that the entire trigonometric equation given to you is written in a single trigonometric identity. There is no other identity for you. All right. So express the given trigonometric identity or trigonometric equation actually in a single trigonometric identity. Like, for example, the entire equation should just simply be in cos, or the entire equation should just simply be in sine or tan. It's not as if the equation should be a mixture of sine, cos, and tan in a single trigonometric identity. But this is going to be if required. Might be so that it is not required. Maybe you're lucky enough that the examiner has already given you the question in what you may call um already the equation has been given to you in a single trigonometric identity, so then you won't have to do much to it. All right, is this fair, Pasha?
Yeah.
Assalamu alaikum.
Walaikum salam, Nopal, how are you?
I'm doing good.
All right, Nopal, we're solving trigonometric identities and we've done that. Now we're going to solve trigonometric equations. All right, okay, now let's do that. And obviously for these type of questions, you're going to have solve for theta is between 180 degrees and negative 180 degrees. So the domain of the equation is also given, which is going to be extremely important as we get along. Okay. Next up, what you're going to have is that obviously, because it says that I need to express the given trigonometric equation in a single trigonometric identity, and over here I can visibly see that my equation is written in cos and sine, I'll convert them. So it's going to be 4 cos square theta plus 5 sine theta is equal to 3. Now, visibly, I know that it is much more easier to convert it to what you may call sine theta, the entire equation to sine theta, because of the fact that cos square theta can be written as 1 minus sine square theta. So it is like already handmade for me as to which trigonometric identity I can use. Knowing this, what can I do? I can write this as 4 times 1 minus sine square theta plus 5 sine theta is equal to 3. Clear?
Yeah.
All right. So this can be further written down as 4 minus 4 sine square theta plus 5 sine theta, which is equal to 3. Very simple. Not at all difficult to do. Secondly, what is going to happen is that I can clearly see that my entire equation, this guy right here, is somewhat resembling that it is some sort of a quadratic equation in sine theta. All right, it looks to me like this is a quadratic equation in sine theta. And because this is a quadratic equation, then obviously I know that regardless of what the variable is, I can solve it. So this looks like to me that the equation is forming to be a quadratic equation in sine theta. Let's see if it is. So if I rearrange all of this stuff, and always I want my squared terms to be positive. So I'll write this down as 4 sine square theta minus 5 sine theta. And it's going to be 3 minus 4, so it's going to be minus 1. Clear? So that is also going to be the case, that it is a quadratic equation in sine theta. Similarly, what's going to happen is that because it's a quadratic equation in sine theta, step 2 is going to be similar to step 1. But this time around, you're going to have what you may call, we're going to use substitution. How are we going to use substitution? That it's simply going to be what you may call that you can use substitution in order to make it a bit more easier for yourself, because in order to solve it in terms of sine theta is a bit difficult. So I can simply use substitution for your equation solving. All right. So you can use substitution, and this is especially used for quadratic equations. For linear ones, it's a bit more straightforward to solve the equation, but for quadratic ones, it's um, a bit difficult. So kindly use substitution. How am I going to use substitution? Let's see. I am simply going to what you may call, let's just write this down. Okay. So what I'm simply going to do is that I'm just going to say that let x is equal to sine theta. Now, what is that going to achieve? Is that simply going to transform my entire equation into 4x squared minus 5x minus 1 is equal to 0. Now this looks unbelievably easy to solve. It's just a quadratic equation in x. Assalamu alaikum, Tariq. How are you? Welcome back.
Alaikum salam, sir. Thank you.
All
Good to
right.
be here.
That is nice. Good to have you, Tariq. We've missed you. All right. Tariq, we're just solving equation. We're doing equation solving in trigonometry. Okay.
All right, sir. Did I miss a significant portion of the syllabus?
I'm sorry.
Did I miss a significant portion of the syllabus?
Not really, Tariq. We have what have we done so far? We have done functions.
Quadratics, functions, and coordinate geometry.
Yeah. 3 topics. And I've just begun trigonometry like I did. We're almost done with trigonometry as well. So, but yeah, no, like almost half of it, but the easier portion, I think you'll be able to catch up. All right.
I think I've taken classes in these lessons before, so
Yeah.
don't worry about
So
that.
it's not going to be an issue for you.
Yes, but I'm talking about part 2, because by the time I've left, there were still some lessons
For what?
for part
Mechanics?
2. Yes, mechanics.
Yeah, that is when I've not begun mechanics in the new session. When that happens in the newer session, then obviously the revision of the entire mechanics will be done again. All right, I had finished mechanics before you left, after you left. All right.
All right. All right.
Okay. So now what's going to happen is that you're going to solve for x. So if we solve for x, what do you get? Can you guys tell me what are the two values of x that we're getting? X is obviously going to be equal to two numbers. So x is equal to something and something. Can you guys solve it, please, and let me know? Yes, Parsa, yes, Nofal. Come on, guys, it's not that difficult to solve 4x.
I got 1.4
Hmm.
and minus 0.18.
1.4 and minus 0.18. All right. Now, this is perfectly all right. Like the two values of x are correct. But there seems to be one issue. X is not x. X is sine theta. So that means x is equal to sine theta, which is equal to 1.4 or negative 0.18. And if that happens, if that is the case, then what do we mean by that is that sine theta is equal to 1.4 and 0.18. But we already know, judging by, when we did the graphs, where did we do the graph? That sine of any angle does not go beyond 1 and minus 1. So that means 1.4 cannot be used. It is not correct. It is not real. Therefore, we can simply say that, this cannot be used. Not applicable. And we're going to be using this guy. All right. Because of the fact that sine theta has to be greater than minus 1 and less than 1. That is why we cannot use this. All right. So we're going to use 0.18. Now comes step 3. Step 3 is very simple. It's just going to be what you may call, it's an optional one as well, because it's not as if it's always going to be there. You have to settle the range. Now, what do we mean by settle the range of the given, what you may call, settle the range of values of x settle the given range of values of the angle. And again, this is going to be if required. If it's not required, then obviously. Now, what do I mean by settling the range? It is going to be very simple. This is the range that is given to you already. It is the angle stated in this range of angles that you can use is what you may call x. Now, for example, if in my question, it had stated like, oh, why am I using x? It should be theta, by the way. Okay. Now, for example, if in my question it had said what you may call 2 theta, then obviously my range of values of the theta angle does not coincide with what my angle in the question or in the equation is going to be. So then I would have had to multiply the entire thing by 2 in order to get to the range of 2 theta, which would have been probably like 360 and minus 360. Clear? So whatever your range is in the question, make sure that that is what is coinciding with the given range of values for the angle itself. All right. In this case scenario, I don't really need to do that. I can simply say that, my sine theta is equal to negative 0.18, and for the given range of minus 180 degrees and 180 degrees. All right, that is just as simple as that. It is not difficult at all. Then what you're going to do is you're going to solve for this. How you're going to solve for this? First of all, you're going to determine through step 4, which is that you're going to determine which possible quadrants could your angle possibly lie in. All right, let's see. So, for example, we already know that the value of sine theta is negative 0.18. So now through that value, you're going to identify the possible quadrants. Possible quadrants in which the angle lies. Okay. Now, because sine theta of that angle theta is giving me a negative value, I can simply say that my angle could possibly lie in what? In the quadrants where sine theta of that angle is negative. So that means that my angle is lying in the third and the fourth quadrant. Common sense. Clear? That means my angle is lying in these two quadrants because you're getting sine theta is a negative answer. That is why you're going to theta must exist in the quadrants where sine of that angle turns out to be negative. All right. Then comes a very pivotal step, which is finding of the basic angle. Once you've determined that, then you're going to, you're very close to the answer. So step number 5 is, you have to find basic angle. Find the basic angle. Now, what is the basic angle? That is what we need to know. The basic angle is very simply what you may call, it is just an acute angle, a positive acute angle, which is your, what you may call, subtended against the x-axis or with the x-axis actually. That helps you find the required angle. So basic angle is, and it's represented by an alpha sign, and it is the positive acute angle subtended with the x-axis. That it always forms with the x-axis, subtended with the x-axis. Clear? So that is going to be your basic angle. All right. Now, how do you find the basic angle? Just like I said, your basic angle is just simply a positive acute angle, which is supposed to exist in your, what you may call, as an acute angle in each quadrant with the x-axis. So that is going to be your basic angle. Okay, let's see now. So sine theta is equal to 0.18. Now you have to find your basic angle. In order to find your basic angle, what you're simply going to do is whatever the value of the angle is, you have to make sure, whatever the value of the answer is, you have to make sure to convert it to positive. Regardless of whether it is already positive, if it's already positive, it's going to remain as such. If it's negative, it's going to become positive. So sine of alpha, which is your basic angle, is going to be 0.18. And that is going to be solved by alpha is going to be equal to sine inverse of positive 0.18. And yes, can someone tell me the value of alpha? Yes, guys. Yes, Nofal, Parsha, Tariq. What's the answer to alpha?
10.37. And just a
Hmm.
minute.
Sorry?
10.37 and 169.6.
No, I'm just asking about alpha.
Yes, it's alpha.
10.36.
10.3736. Okay.
Yes.
Okay. Why don't I just put it as 10.4? All right, rounding it off. Clear, guys? Any questions regarding this, Parsha?
No, so no questions.
All right. Now comes the last and the final step, which is probably the easiest one. You've got everything, all the ingredients of finding the answer are there. I just need to put them together. So step 6 finally just states that find the required angle. Now, how you're going to find the required angle is very simple. That you're simply going to be what you may call using the range provided to you, above which we just settled, the quadrants in which the angle lies, and the basic angle. All right, now how will I do this? I know for sure that if I try to construct my graph now, so now I know that first of all, I'm going to use my range. Now, what is my range? My range is that theta cannot go beyond what you may call 180, from negative 180 to positive 180. So first of all, I need to determine that. So obviously it's going to be 0, 90, 180. And if we go into the negative quadrants, it's going to be what you may call 0, negative 90, and negative 180. So technically your range is in the positive quadrant, it is just like this. And in the negative quadrants, it is what you may call from 0 to 180. Clear? Okay. Now let's see what sort of difference that is going to make for our angle. All right. So now what's going to happen is this is our range, and now we know that our angle cannot exceed this value. Okay. Let's see. So what is going to happen is that the value of my angle, or the value of my basic angle essentially, is what you may call 10.4. At the same time, I know that my angle is going to lie in these two quadrants. But the problem is that my range is from 0 to 180, and it is from 0 to negative 180 and from 0 to 180. So obviously in the above part of the range from 0 to 180, my angle cannot lie, because essentially we already know that my sine theta was 0, negative 0.18. So sine of that angle was negative, therefore it cannot lie in this. So my angle can only exist in these two quadrants. Secondly, what is basic angle? Now basic angle is going to play a huge role. Basic angle is the angle subtended with the x-axis. That helps you find it, the required angle. So the basic angle is always just simply what you may call the angle which is forming with the x-axis in all the quadrants. So it's going to be, this is your basic angle. This is your basic angle. And similarly above as well, your basic angle is forming with that. But we don't require it. We require our basic angle only in these two quadrants. Why? Because our actual angle is going to lie in these two quadrants. Now, if I'm going to measure my angle in these two quadrants and I know that it cannot exist in the positive range, then obviously my angle is negative. So first off, my angle is equal to what? This is my first angle, right? My angle is from 0 to the basic angle. So technically in this quadrant, the fourth quadrant in the negative one, theta is equal to the basic angle. And my second angle which is forming is simply this guy, what you may call this one. Because I'm going to have what you may call. Now, how do I measure this? Now, this is also equal to theta, but this time around, theta is technically equal to 180 minus the basic angle. So minus 180. Oh, sorry. Technically, it's going to be alpha minus 180. Clear? These two are my actual angles. And how did I find them out? I used my range, I used where the possible quadrants could be, and I used my basic angle. So therefore, my angle is going to be theta itself is going to be equal to what you may call basic angle is 10.4. And but this time around, it's not going to be 10.4 because you're measuring theta in the negative quadrant. So it's going to be minus your basic angle because of the fact where it is being measured. Then it's going to be minus 10.4. And alpha minus 180 is equal to what, guys? 169.6 or something like that.
Yes, you're right, sir.
That will be your answer. Clear? Is there anyone who does not understand this? Let me know.
No, sir, I get it.
Nofal, any issues with this?
No, sir.
All right. So that is how you simply solve an equation using a bunch of handful steps. Clear, guys? Hopefully this is clear. I used one example and that should be sufficient enough to, make you understand that how am I getting my angle. Now my range did extend beyond 1, but the problem was that unless and until my range went for a complete circle, complete rotation, I could not have used my positive side of the range. Why? Because the quadrants are going to be the third and the fourth one. Clear, guys? Now, usually what happens is that questions like these can come for, up to well above 4, 5, 6, 7, maybe 10 marks as well. And the thing I want you guys to know is that students think that the identity proving question is somehow related to the question that is, that we're doing right now. Okay, to some extent it may be related, but it's not as if you cannot solve the identity proving question, you cannot solve the equation solving question. No, that's not the case. These are separate. What is happening is that your equation solving question is completely different. It implies a completely different method, whereas your identity proving one is different. So do not try to think that okay, if the two parts are related, I cannot do one and end up losing more than 10 marks. At least attempt the equation solving one and leave the identity proving one till the end, because sometimes it does happen that the identity proving one is not that straightforward and you have to think about it. This, however, is going to use these same steps all the time. So it's not going to be an issue for you. Clear, guys? All right. Now I'll show you one. Okay. This was the question that, we did it in class the other day, where, it was an identity proving question worth 3 marks. Show that tan theta over sine theta minus sine theta over tan theta is this. And it was really easy. You just simply had to use some trigonometric identities. Tan theta is equal to sine theta over cos theta, a bit of simplification and stuff of that sort, and you got your answer. Clear? Now I'm going to give you, because this is actually part B of that question. And now where is the rest of the question? I'll give that to you so that you guys can solve it. Wait. It says show that. All right, this was the entire question that I was talking about. That this was the first part of the question. By obtaining a quadratic equation in cos theta, solve the equation. It's about 5 marks. And then part B was the question that we attempted in class. All right, wait, let me swap pages. All right, so we have already done part B. Now you guys need to do part A. All right, can you guys attempt part A and let me know how you're going to, let me know when you're done. Okay. All right, kindly solve this question and let me know when you're done.
Okay, Mr. Done.
Well done, Parsa. All right. What's the answer?
So do I just go through the whole question, or do I just say the final answer?
No, just say the final answer.
Yeah. So I got theta as 51.7 and 308.3.
Yes, Nufal and Tariq, do you guys agree with him?
Yes, sir. Same answer.
Tariq, what about you?
I'm not done yet, but almost.
And I checked on my side as well. That is the answer as well. Yes, Tariq, you're still solving?
Yes, but I'm almost done, sir.
All right, no worries. It was really easy. It was pretty straightforward, this one, because you didn't really have to do a lot of stuff to, change up the tan theta and the sine theta into anything. And it was like really, really easy to do so. It wasn't that hard. Like, it wasn't hard to convert the entire equation given to you into a signal trigonometric identity equation. And then it became, I hope you guys did it the same way, but if I were doing it, I would have made it into an equation and a quadratic equation in cos square theta. And then simply using my basic angle, my range, my quadrants, and everything else aligning with it, I found my angles. Clear? Yes, Tariq got the same answer.
Not yet.
Okay, no worries. All right, so boys, we're going to keep it till here for today. Well, we have a class tomorrow, so we're going to be what you may call continuing on with this. Okay, we'll try to attempt more questions, and then we can, if we've got time, we'll try to move on next to series and progressions. All right, well
What
done,
was the
everyone.
answer, sir?
51.7 and 308.3.
I got 51 too, but 51.8.
You got 51.8. It's okay. I think Parsa and Nofal have also rounded it off. Are you getting in this vicinity? Is the whole number correct? Are you getting this whole number?
Yes, 51.
Then that's not an issue. All right, as long as you're getting the whole number, then that's not an issue. All right. Okay, well done, boys. And also, your attendances will also be taken from here on out in classes. So kindly do join on time. And guys, the class timings, everyone knows about them. They're from 7 to 8 p.m. Pakistan time. And the class and the link is the same, the one that you join in. So do not expect me to send you the link in every class. I might begin and I might forget to send you the link. I will try to do so, but even if I forget, you guys should just join anyway. All right. Nonetheless, keep smiling, boys. I'll see you guys tomorrow. Bye bye. Allah Hafiz.
Bye, Mr. Take care.
Office.
Allah Hafiz. Bye bye.